Okay, so still, in 1.6, we're now looking at how to solve the radical equations. Okay, I have mentioned in class that radical equations means they contain roots, either square root, cube roots, or fourth root, fifth roots, whatsoever. However, the good thing in this class is that since we're all beginner in algebra, the only type of roots that we are concerned about is the square root equation, I'm sorry. So once again, you don't have to worry about solving those equations involving cube roots or fifth roots whatsoever, square roots only. But then we might encounter with a 2 square root problem or 1 square root problem. So now let's look at some of the example here. Some more example here. So my example number 1. So now I want to solve the square root equations that contain square root of 3x plus 18 equals x. Okay? And now this equation here, once again, if you observe throughout the whole equation, there's only one radical term, there's only one root term. So, in other words, this equation, we're calling that one radical term, one root term. Okay. And now, during our discussion in class, I mentioned always, as the step before anything else, you always need to do the isolation. You need to bring all the root terms, all the radical terms to one side, and bring all the non-radical terms, all the non-root terms to the opposite side. So here, my equation here, it's already started out ready for us. We have one root term ever, and that appears on the left side. And there's only one non-root term, and it's already on the right-hand side. So we're good to go. So now, to solve for this equation, the only remaining, once you finish isolating the terms, all the roots goes on one side, on the non-root, go on the other side. All you have to do now is square both sides as the way it is. So now my right hand side is an x, and you need to square it, so it's become x squared. My left hand side, the whole left hand side, is a 3x plus 18. Okay, and you need to square it. So it's going to be all that square, and then there's the equal sign in between them. Okay, I need to extend this a little to make it kind of all in one line. Okay, so now after squaring both sides, my right hand side will become x squared, just simply that. My left hand side, the whole point of squaring both sides here is because we want to get rid of the square root right there. So the square canceled with the square root give me just simply 3x plus 18. So that expression comes straight out. 3x plus 18, no more square roots. Okay, and so now we are free from square roots. If you look at this final equation that we have just looked at, that we have just finished up to so far, this current equation right now, that is a quadratic equation. All you have to do now is just simply rearrange the terms so that you can start solving it. So now I can see that, now I prefer to keep my squaring term positive, so I'm leaving the x squared on the right hand side. I'm going to subtract 3x and subtract 18 from both sides. And that is going to leave me x squared minus 3x minus 18 equals 0. Okay? And now, if you're not comfortable seeing the 0 on the left-hand side like this and all the terms on the right-hand side, this equation here is logically the same as x squared minus 3x minus 18 equals to 0. Now, if you can just simply turn the equation around just like that, it's going to make it much easier to see, isn't it? And so, at this point, it's just simply back to the plain old quadratic equation that we've spent a huge amount of time learning how to solve it. And so, if you're not sure how to solve these, once again, check back with those videos that we've had earlier about quadratic equation and pick up on the technique there. But then with this one here, it's simple enough that we can just simply start out with using the solving by factoring. So I factor the x squared minus 3x minus 18 into x minus 6 and x plus 3. Equals 0. So now immediately that gives me x minus 6 equals 0 and x plus 3 equals 0. Right? And then solving for it, adding 6 to both sides in the first equation, that gives me x equals 6. One solution. Actually, not quite. So I'm not going to, x equals 6 is one answer, but I'm not going to rush into circling it yet. The other equation, subtracting 3 from both sides, x equals negative 3. Now, the reason I'm holding on to the circling the final answer here because these are not my final answer yet. one of the critical part in radical equation that we have already discussed in class. We need to check each of these solutions here to see whether it works in the equation, in the starting out equation. So you need to do the checking step in these problems. So now, for x equals 6, okay, let's check how it works. You plug it back into the starting equation. The starting equation is a square root on one side and 3 times 6. Now, because I'm plugging 6 into the x of the equation, plus 18. Okay, and let's see, is it just simply equals, and that's why I put question mark over here, is it simply just equals to 6 on the other hand side? And let's try to find it out. 3 times 6 underneath the square root is an 18, and 18 plus 18, and take square root, is that equal to 6? And yes, you can see it, right? 18 plus 18 is 36, with square root, it does equal 6. So now at this point here, you check for that. And so now you're going to go back and circle your answer right there, because that first solution now does work for the equation. You also need to check that for the other equations, for the other solutions. So now for x equals -3, let's see if it works. Okay? We're plugging it in to the equations. We've got 3 times -3 plus 18. Is that all going to be, after computation, is that all going to be equal to -3 on the other hand side? And let's try to find that out. -3 times 3 is a -9 plus 18. Okay? Is that still going to be equal to -3? Okay? And we don't know that. So there's one more step. 18 minus 9, that's giving me square root of 9. Is that equals -3? The answer is no. Why is that? Because square root of 9 equals +3. We only have square root of 9 equals -3 unless if you have a negative sign in front right here. But here we got we're talking about a positive square root of 9, so it's not equal to -3. That is why, even though you have found two solutions, but this second one here is out of the line. We're not going to take that. So the real final answer is to this equation here. It's only x equals 6. It's your only final answer. So remember, you need to check for your solutions. So let's now look at example number 2. And we're solving radical equation again. So let's say you got 2x plus 13 equals x plus 7. So once again, what's the good thing about this equation? First of all, it has only one radical term. You look throughout the two sides, there's only one radical term. Even though it's a long radical term, but it's just one radical term. Okay? And also the good thing, it's already up here isolated. The equation itself appears to be isolated. All the radical terms on one side, all the non-radical terms on the other side. So here once again, there's only one radical, one group term. Keep that in mind, it's just something to help you notice. Well, later on when we start dealing with some of the two radical terms equation, things are going to all of a sudden become significantly much more challenging. So once again, at this point right here, all you have to do is square both sides. So my right hand side, to square it, make sure you square the whole thing. So x plus 7, all squared. The left-hand side, once again, you square the whole thing. So all that, 2x plus 13 underneath the square root, you need to square all that. And setting the two sides equal to each other. And so now, please, this thing is not going to just be equals to x squared plus 7 squared. That's wrong. Remember, you have to FOIL the right-hand side to get it out of the square right here. So after you FOIL, it's going to become x squared plus 14x. Plus 49. That's how you FOIL the square on the right hand side of that equation. Think about x plus 7 times x plus 7. That's the meaning of x plus 7 all squared again. The left hand side, once again, is similar to example 1 we had earlier. X squared, cancel away with the square roots. That gives you just simply 2x plus 13. Now, if you look at the two sides, once again, you're back to a quadratic equation. You got a squaring term, some x term, and all the non-x terms. So now you need to clean up all the terms, rearrange the terms. I'm going to subtract 2x from both sides and subtract 13 from both sides. And once again, I mentioned earlier that I want to subtract in a way that I want to rearrange the terms in a way that I want to keep my x squared term positive. Here, the x squared appearing on the right hand side is already positive itself, so I need to subtract 2x and 13. Minus 13. Here I have the 0 on the left hand side. I have x squared plus 12x plus 36. Okay. So now my equation at this point, and once again, if any of you is not comfortable with looking at the equation this way, where you see all the terms on the right hand side and a 0 on the left hand side, you can just simply turn the equation around. You have x squared plus 12x plus 36 equals 0. Just like that. Now it makes it much easier to solve the quadratic equation. So for this quadratic equation, once again, you have a good variety of ways to solve it. But then what I can see is factoring is my quickest one to get into it. So now I have x plus 6 and x plus 6. And that's how you can factor the x squared plus 12x plus 36. And so immediately you're going to produce x plus 6 equals 0. And the other one, x plus 6 equals 0. And once again, here you're going to expect the two identical answers. So you only have to encounter it all just one time. You only have to count the solution one time. So they're just going to be the same. So I'm going to only look at one of them. X equals negative 6. And that's my, so here I only found one solution ever, because even though you have two separate ones to solve for, but in the end they just turn out to be one same number. So now, I'm not going to rush into circling my answer yet. I need to check my answer to see if it's really the one that's working for this equation. So now to check, okay, so my checking step. Left hand side, long square root, 2 times negative 6 plus 13. Let's see if it works. And then on the other hand side, negative 6 plus 7. I'm just simply plugging 6 into the appropriate x places. And so now, let's see if the two sides here are going to be equal out. The left side is going to be equals to the square root of negative 12 plus 13. And the right hand side is just simply a 1. It's negative 6 plus 7 is a 1. And once again, we would like to find out if the two sides are equal. The left hand side, one more step further. Negative 12 plus 13 equals square root 1. Is that really equals? Square root 1 equals 1? The answer is yes. Now, you put a check there. Here's your, now you can safely go back and circle your final answer. So x equals negative 6 is one of the answer. Is the only unique answer that we found.